Uh, Good evening, everyone, and thank you for staying back to listen to the talk. I'm Syed Azeemuddin, the last author there. I am the presenter. This work is done by my student, and for visa problems, he couldn't come. And I was here in US, so I am presenting this work mostly done by my collaborator who is there in Software Engineering Research Center. His name is Raghu Reddy. So I'm trying to present my collaborator student work over here. So this work is about gait analysis. So in the morning, we have heard Dr. Sara talking about correlating gait analysis work to the brain health. And in the invited talk, Dr. Professor Samir talked about gait analysis using thread. This work is about creating a mat. And if we can use that for gait analysis and study the natural walk, and it has various applications. And the application which we had in mind was to correlate that with mental health, but we didn't do that in this research, but we are continuing the work with a cognitive science professor. So it's part of the work of the student. And it has to complement with the questionnaire, as it was mentioned in the morning also, that we have to ask questions to the patient and correlate that with this to get the assessment. So right now, basically, gait analysis is done by using cameras. And the other way to do the gait analysis is for the pressure sensing shoe. And another way which is proposed is we can use the mat also. So if you use the mat, the problem of privacy will be gone. So people don't want to be in the camera to get analyzed. Another problem if you use the mat is you don't want the patient or anyone to use the shoe. So you can put it in, you can gel it in the carpet and then keep it in the home, and then you can start sensing even anybody walks on it. So, and you want that mat because if it is large size, like let's say 10 feet by 12 feet, you want it to be cost effective, because if it goes into the carpet, already carpet cost expensive. Then if you put an expensive layer in the carpet, then it will become more expensive. So how do you bring it without any, cost on the carpet? Let's say the carpet is $1,000. So this should be costing $10 or $100, so that the correlation should not work. So that's one thing. So the idea was if we can use existing commercial material for that. So there is one material called as Velostat. That material is usually used for packaging electronics purposes, so that electronics get saved from electrostatic shocks. So can we use that packaging material and make a mat out of that material? And as a pilot phase, 1.8 by 1.8 feet has been made for this work, but parallelly, we already made a 6 feet by 10 feet also. We're going to write a journal for that work. So in this work, only one thing has been reported, that is how to calculate the stance phase of the gait-cycle. And the sensor design is done by using that Velostat material and sandwich that between two orthogonal copper linings. And then these copper linings, we can connect it through, show you in the next slide, that copper lining ending can be connected to the microcontroller to start sensing the change in voltages because of change in resistances. And for analysis, we have done both. So each, if we run the copper vertical and horizontal, so we are making a pixel kind of thing. So we are calling that as sensors. So we can make, to try to see if we can have less sensors, what it will be, whether we can create good images, or more sensors, we can get a good image on that. So pretty much is very simple architecture. So if we can connect, if you see the model of it, so we have a fixed resistor which is to the ground, and the other resistor is nothing but Velostat, which is variable resistor based on pressure, and connect to the supply. And whatever is the voltage divider, change in voltage can be sensed out through the microcontroller Then that microcontroller data can be transferred to a computer for data visualization through Python scripting there. So what are the issues you may come across? One of the issue will be crosstalk. So when the copper lines are continuous in nature, so you will see that when I put a pressure here, then the sensors here, all the pixels here will also sense that change in resistance. How do I get rid of that crosstalks? One of the issue we thought that we can cut that continuous cross coppers and then have a pixel-wise copper arrangement. Another idea we thought of putting all the horizontal and not putting the vertical. Another we thought we will have a complete copper and then let's see. So all of the hardware techniques to address this crosstalk were failed. We couldn't get any improvement there. Then we decided that let us try to, anyway we are taking the data and then we are feeding it to a filter. So let us try one filter. Then we tried one uniform filter wherein we are saying that any sensor, if it has some data which is uncorrelated with the neighboring, let's get rid of that. Let's filter it out. As a result, when we do that at a software level, we were able to get a very nice pictures out of the sheet. And then we thought that yes, we can do a stance space calculation wherein is nothing but when we land it is the time 0 basically, and then when we lift our toe, it's like time, final time, and then let's try to find out this time and store it. So that's what is we have done, and we have calibrated or validated in fact. So validated against a commercial mat which is costing around $1,500 with the same size. Sensing Tex is a company which sell a mat. We don't know what material they use, and our mat was costing $50. And of course, we didn't add the cost of software that can be added as when it goes for commercial. But if you see, there's a huge difference between those two costs, and we are able to get the same results when we validate against that, around 95% accuracy. In this period, we also seen that typical walking styles take a landing and then flying will take around approximately 0.79 to 1.1 second. We want to know this because we can then improve our scanning times there. So we decided to use the default clock of the microcontroller. Then we applied a change in the prescalar value and we improved the frequency there, and we were able to reduce the scan time. Another thing we also tried in this work was to see if we know on what pixels the person is putting the foot. So can we just take the data of that sensor and get rid of all the other sensors on the mat? We tried that we named it as linear code. And then we thought, let's use the data from all the sensors and see whether we are getting a better result. We have also recorded that and we called that code as a mux code. And we compared all these scenarios with 15 by 15 sensors, the density basically, sensor density 30 by 30. And then we changed the prescalar value to increase the scanning time, to improve the scanning time, like to reduce it. And then we also tried this only sensors on which we are putting the foot or all the sensors. And then we finalized that the P16, that means we have a scalar in which we are reducing the scan time and the data from all the sensors. When we run the code for that, we are able to get the better results. That's what our conclusion was. We have also done another analysis in which we found that how do I increase the range? So let's say if I put a pressure of 2 kg, if the voltage is 3 volt, now I want to increase it by 100 grams. What should be the next voltage step? How do I increase the contrast in the voltages? So we thought in order to increase the contrast, we can increase number of Velostat sheets in that, and the sandwich can become a little thicker in that. So we have done that analysis and we have observed that we can increase the range by adding more Velostats, but as expected, the sensitivity will fall down. But it will not matter so much because the weight of a human being is a lot. So we can accommodate that less reduction in the sensitivity, and we can have a more better range of voltages. So in conclusion, we have done an analysis and we named this mat as Velostat gait-mat. So we just named VelGmat, although it has no copyright, so we just named it. So it has we have done analysis on sun cell density, crosstalk, scan time, and sensitivity and range. And it is a very good candidate to go into commercial mats as a sandwich layer. And those mats can be sold out to people, even to healthy people, to be there in their homes when they walk it without any feeling that someone is watching me, which can happen in Kinect camera based sensing. And then a whole lot of things can be done now. Stride length can be measured, stride velocity, like how fast a person is walking, wobbling effects can be seen, cadence can be seen, a complete gait cycle. A lot of data can be created from which could be fed to the psychologists, right? And then correlate their mental states, which was discussed in today's keynote lecture, and these parameters. And if we can find a good correlations by putting some regression analysis there, it will be a nice area of research for a PhD or for a commercial application.